You know, if you work in water treatment, you see those two letters, P and H, pretty much every single day. But what does that number really mean? Well, today we're going to break down why this simple little measurement holds the power to either protect or completely destroy an entire plant.
Look, it's easy to see pH as just another number you gotta log in a spreadsheet, right? But what if it's actually telling you a story? A story about the invisible chemical battles that are happening inside your pipes at this very moment. As we're about to see, it's probably the single most important clue to what's really going on in your water.
Okay, so let's start at square one. What exactly is pH?
The easiest way to think about it is like this. pH is a spectrum, kind of like a ruler for chemistry. It runs from 0 all the way up to 14, and it tells us just one thing. Is a solution acidic, or is it the opposite of that? Alkaline, which, we also call basic. Now, the magic number on this scale is 7. That's your sweet spot. It's perfectly neutral. Anything that falls below 7 is considered acidic, and anything that goes above 7 is alkaline. That's it. It's a really simple, elegant system for understanding the basic nature of any solution. To make this feel a little less abstract, let's just look at a few things you can probably find lying around your house. You can really see the massive range here. I mean, way over on the acidic side, you've got lemon juice sitting down around a pH of 2 or 3. Then in the middle, you have drinking water. That's our neutral 7. But then look at something like washing soda. It shoots all the way up to 11 or 12, which makes it super alkaline. You can see just how different these things are, chemically speaking, all from this one number.
So, that's the kitchen. Now let's take this same idea into the industrial plant, where getting the pH right isn't just a matter of taste, it's a matter of survival for your equipment.
See, when your pH gets out of whack, you're basically facing two main enemies. If it drops too low, it becomes acidic, and that starts a corrosive process that literally eats away at your pipes from the inside out. But if you swing too far the other way, into alkaline territory, you get scaling, a problem that's every bit as destructive. So what is scaling? It's what happens when minerals in the water, like calcium carbonate, decide to drop out of the solution and form this rock-hard crust on everything. This deposit basically acts like cholesterol in an artery. It clogs up your pipes and just chokes the efficiency of your entire system. And this, right here, is why operators live and breathe pH monitoring in these critical areas. Whether it's in a heat recovery steam generator, an RO plant, or in the boiler feedwater treatment. A pH that's off by even a tiny fraction isn't just a bad reading. No, it's the first major warning sign of a potentially catastrophic failure down the line. Okay, so we know what happens when pH goes wrong. But to really get it, we need to kind of peek behind the curtain at the chemistry that's pulling all the strings. Now, this little formula might look a bit technical, but trust me, it holds the secret to why pH is so incredibly powerful. This right here is the engine that drives everything we've been talking about. So what this formula is telling us is that the entire pH scale from 0 to 14 is based on one tiny little particle, the hydrogen ion. The more of these hydrogen ions you have floating around, the more acidic the water becomes, and the lower the pH number gets. And here is the absolute key. Because of that log in the formula, the scale isn't linear, it's logarithmic. What does that mean? It means that a tiny, almost unnoticeable change in the amount of hydrogen ions can cause a massive swing in the pH value. It's the reason why adding just a tiny bit of a chemical can make the pH jump so dramatically. So, after all that, what's the one thing you really need to walk away with? It all comes down to this. pH is never, ever just a number you write down in a log. It is the vital sign of your water's health. It is the foundation that the entire water treatment process is built on. Get the pH right, and everything else has a chance to work. So that leaves us with a question to take back with you to your plant. Think about your most critical systems. What's the target pH you're aiming for? And now that you know its power, really think about why that specific number is so incredibly important. Thanks for tuning into this explainer.